to talk today a little bit about a pilot project that we put together for the Anaheim Convention Center. It started from HP Labs and an application called Phoenix, which was used to monitor the energy consumption of a home. But this application had much larger reach and potential. So we looked for kind of an active client-facing pilot project, and what we did was we partnered with the Anaheim Convention Center. The Anaheim Convention Center, as we know, is a very large convention center, largest on the West Coast, high energy use, lots of major shows coming in and out of the doors there. So we created what we call the Anaheim Resource Kiosk. And looking at the facility, it's been built over a number of years. The original facility was built in the 1960s. So we concentrated on what they call Chiller Plant 1, which provides the HVAC for the original building. These here are the Delta controls that we acquired through a local industry partner. And these controls were tied into what is called the Motor Control Center. This Motor Control Center is what actually provides the power to the Chiller Plant 1. Based on the information that we were able to grab from that chiller plant, we were able to start looking at not just the generic utility consumption, but we were able to start looking at specific locations and areas within that facility. Within that, we could run these real basic reports, but these reports were starting to provide information that was based on a location instead of a general area. We were also able to look at those areas over time, and we could see spikes in energy consumption, which we were able to relate to an integrated occupancy report that we were also able to pull. So through this report, we could see what was going on where in that facility, and we could match our data to that. Beyond that, we could dig even deeper, and we looked into specific pieces of equipment. So now we've gone from a generic utility consumption for an entire facility. We started looking at smaller areas, and then now we're looking at the specific equipment that provides the cooling for those areas. What we really found with this presentation was that the right energy management solution could provide the insight into building efficiency levels and operating costs. In addition, it could identify cost-saving measures to reduce the energy footprint. By increasing the transparency into government building efficiency levels, and it also allowed for the application of extra LEED certification credits, which today is an important factor in maintaining our efficient buildings and showing as an example to businesses and residents that what we're doing is something that can carry through not only in the public sector but also in the private sector. One of the roadblocks that we ran into was this reliance on adequate sensor data, but was it really there? And with that, I'm going to introduce or reintroduce Amip to move this technology forward.
Thanks, Mike. Can you guys hear me in the back okay?
Yeah.
Apparently I have a PhD in 70 patents, but I can't use a mic properly, so I'm going to go micless this time. Part of the cool thing about this project, and this is kind of geek as sheep, but innovation doesn't work the first time. It's this process of continuous adaptation where you start off in a particular direction and course correct as you're going there. And that's where we are with our entire energy management and more broadly infrastructure analytics program at Labs, where we've developed stuff. This program is over 7 years old now, and we've tried stuff out in the field, and we're now in the process of course correcting. As Mike mentioned, one of the challenges one of the premises of the original solution was that sensor data would be available. Our HP lab site had 16,000 sensors that were installed over the field. Unfortunately, big data is not necessarily good data, right? There was a lot of information that we could get which was different from what we needed. So we were talking to our internal team at HP Labs about rolling out a smart building front. Yeah, this is great. We can get energy efficiency, we can improve tenant satisfaction, blah, blah, blah. The next question was, all right, we need to install about 60,000 sensors. Our model suggests that by the time you've added in the sensors, added in the network cost and the lifecycle management cost, it's about $1,000 a sensor, even if it's a $10 piece of hardware. You guys have about $60 million lying around by any chance? I'll let you give my answer. But the key that we realized then was the cheapest sensor is one you don't need to install. Right? The cheapest sensor is one that either already they're being used for something else. For example, right now in this room, I have well over 100 sensors. Right? Each of these guys has about 12. Now, the sensors in this were meant so that I can actually rotate my screen, but it also has a Wi-Fi radio that tells me when I'm connected to the network. So what we did was we said, hey, can I just use the network connection as a proxy for a sensor and tell when somebody's in a room? Right? Next thing we say, okay, now we have motion detectors distributed throughout the building. In a hospital, what if we make that more sensitive? Can we actually then use that for security? When we're saying, look, you can tell if somebody's actually walking in a ward where they're not supposed to, but can I tell if a patient's actually unable to roll over bed? Because that's the analytics capability we have now. So those are the types of innovative things that we've been trying to do. The key to realize is that it's a four-step process. Right? The first piece is what Mike described, which is really about instrumenting, understanding what data you already have. The next several analytics capabilities that we have actually try to drive towards the business value. And I'll just give you a couple of quick examples about how that works. What you're seeing behind me is a map of a worldwide company. It's a large company based in Palo Alto that works in the IT industry. It's actually real data. What we said is, you know what? Every building or every site gets a utility bill. That's the source of data that's available to us. Before we go around trying to instrument the heck out of all of these, spend $60 million, what if we just look at the utility bill data and try to run some analytics on that? And what you're able to see here are a clustering algorithm, a statistical process by which we've identified similar buildings based on climate, what they're being used for, so on and so forth. That's the color, right? And the size of the circle tells you how much energy they're consuming per square foot per person, so they're normalized in a way. So what you would expect is if you have two identical buildings of the same size being used for the exact same purpose, those circles should be the same. The reality is if you look, and you see that in some cases, if you look at some of these light green dots, which are basic, or the orange dots, right, which are basically building, office buildings in hot climates, they're about the same. You look at the green dots, right, what the heck is going on in India? And you look at the brown dots, like what the heck is going on in Australia, right? And the idea is saying, hey, we just said instead of looking at all of HP 400 sites, we're going to focus on 8. So we just went from 60 million to whatever else that was. And by the way, this portion of analysis, no extra spend on hardware. Right? So if you're in city, however many city buildings you have, it's an easy place to get going. The next thing we do is said, all right, we're now going to try and integrate with existing data feeds that exist in the building. One of my favorite examples is there was a site that had about 6 buildings. 5 of those buildings had air conditioning equipment that came on at 6 a.m. and shut off at 6 p.m. There was one building that came on at 4 a.m. and worked till about midnight. Could not figure out, their team of PhDs at this thing could not figure out why that was. Apparently, there was a manufacturing shift that started at 6 a.m. They wanted to pre-cool the building, and every once in a while they had a night shift, but they had to run the equipment later. What nobody told us is that they haven't done manufacturing at that site in over 30 years. So we updated the manufacturing work shift. Nobody went in and tried to and updated the air conditioning schedule. You think about just the cost of that over time building up, and in many ways this program already paid for itself. I'm not going to go through the details of this slide. There is a video at the back that we can show animating. This is giving you an example of something that we call the anomaly detection. Effectively, think of it as a piece of equipment. It can be an air conditioner, it can be a car, it can be a road, it can be a bridge, tweeting its own sentiment to you. That's effectively what it's doing. If this guy is red, it's a negative sentiment. If this guy is green, I'm happy and dandy, don't worry about it. Think about how the power of an application like that. You can immediately tell if something needs maintenance, because guess what, when things start going wrong, all of a sudden you start seeing more and more red come in. If your car is actually driving and hits a pothole, you can automatically now realize that if the driver of the car is willing to share that information with you. So now you actually know when you should send a maintenance crew to fix it. If you're actually running a utility and a pump is coming up on a capital replacement, you should actually be able to tell if you're hitting end of life or not. So ultimately what this is doing, to go back full circle to where I started off the very first in the beginning, is we are making real this notion of cyber-physical systems. Right? We are taking physical systems, adding an intelligence to them, layering on analytics capabilities, and actually trying to fundamentally change business processes. So that's really where we're hoping to go with this work. One of the first cases we are instantiating this is in smart buildings. That's an internal pilot at HP. We've started a couple of external pilots as well, but we're using that same technology stack, that same solution then, to apply to fleets of vehicles, to apply to smart homes, and to truly build this next generation cyber-physical infrastructure. If I'm invited back here 10 years from now, hopefully you're going to see this working at city scale for all of Anaheim. That would be my dream at least. So with that, I'll turn it back over to Chris.